In the world of aviation, few aircraft inspire awe like the Concorde, a supersonic marvel capable of crossing the Atlantic in under 3.5 hours, cruising at Mach 2, twice the speed of sound. Its sleek, needle-like shape made it instantly recognizable. But behind that elegance lay one of the greatest engineering solutions ever conceived: the drooping nose. The challenge was simple to state but nearly impossible to solve. To slice through the air at supersonic speeds, Concorde needed a long, pointed nose, streamlined, razor-sharp, and aerodynamic. But that very nose blocked the pilot's view during takeoff and landing. Imagine trying to land a plane faster than sound without seeing the runway. A single misjudgment could have been catastrophic. Engineers came up with a bold solution. They made the nose hinge downward. During approach, the nose would tilt down by up to 12.5 degrees, giving pilots a clear view of the runway. At cruising altitude, it snapped back flush, transforming from a tool for visibility into an aerodynamic weapon for maintaining speed. The mechanism itself was a marvel. A triple redundant hydraulic system controlled the movement. If the primary system failed, backups kicked in. If all systems failed, gravity itself would lower the nose safely. Every landing was a precise dance, relying on hundreds of components working in harmony. This idea wasn't entirely new. It traced back to experimental jets like the Fairey Delta II, the first plane to exceed 1,000 miles per hour. But Concorde was the first to adapt it for commercial passenger service, turning a daring military concept into a practical, safe solution. When the Concorde descended, the nose dipped gracefully, and the delta wings maintained lift at the steep approach angles. To the untrained eye, the landing looked dramatic, even precarious. But for pilots, it was ultimate control. Landing Concorde was like balancing a dart on your fingertip while threading a needle at 187 miles per hour. Every movement mattered. The drooping nose wasn't just a gimmick, it was essential. Without it, pilots would have had to rely on guesswork or risk dangerous landings. It was the difference between supersonic innovation and disaster. Yet the drooping nose was only one example of Concorde's genius. The aircraft faced extreme heat at Mach 2, causing the fuselage to expand by up to 10 inches. The cabin walls radiated warmth, a subtle reminder of the ferocious forces outside. Engineers used a special aluminum alloy strong enough to flex and light enough to fly, and a reflective paint to deflect heat, allowing the plane to withstand supersonic temperatures safely. Concorde's engines were another wonder. The Rolls-Royce Olympus 593 engines used variable intake ramps to slow supersonic air to subsonic speeds before reaching the compressors. Most supersonic jets require fuel-guzzling afterburners to maintain speed, but Concorde could supercruise at Mach 2 on dry thrust alone, a feat no other commercial airliner has ever achieved. Even the fuel system was ingenious. Fuel wasn't just for power, it acted as a liquid heat sink, absorbing the intense heat from the airframe and cooling other systems. And the Concorde was early to adopt fly-by-wire, using electrical signals instead of mechanical linkages to control the aircraft, with triple redundancy for safety. Inside, the cabin was intimate and exclusive. Just 100 passengers in a tube 9.5 feet wide. Small windows preserved structural integrity at 60,000 feet. Luxury didn't take a back seat. Caviar and lobster were served while passengers soared above the clouds almost at the edge of space. But Concorde's magic wasn't only about engineering, it was also about the unique experience it offered its passengers. At cruising altitude, the sky transitioned from deep blue to inky black, with the Earth's curvature visible. Thunderstorms were distant, and air traffic virtually non-existent. Concorde didn't just fly higher, it redefined the experience of flying. Even its name sparked diplomatic discussion, with the final E symbolizing excellence and Anglo-French cooperation. Yet behind this elegance was an invisible force that made everything possible: hydraulics. Hydraulics powered nearly everything: the drooping nose, landing gear, flight control surfaces, and even the variable engine intakes. With 3 independent systems ensuring reliability under extreme pressure and heat, Concorde could perform its complex ballet in the sky with absolute precision. But brilliance often comes with a cost. Despite its engineering triumphs, Concorde remained commercially limited. Only 20 aircraft were ever built, with 14 entering service. The combination of high development costs, immense fuel consumption, sonic boom restrictions, and limited routes prevented it from becoming mainstream. Still, for those lucky enough to experience it, flying Concorde was never just travel. It was an event, a glimpse into the future of aviation. Even in retirement, Concorde's legacy continues to inspire. Today's engineers are once again pursuing the dream of supersonic flight, striving to overcome the same challenges of noise, efficiency, and speed that once defined the Concorde era. The drooping nose of Concorde stands as a reminder that true innovation often begins with solving a simple yet critical problem. It has become a symbol of human ingenuity, where beauty, function, and physics meet. Every time we see a Concorde in a museum, we see far more than just an aircraft. We see a lasting testament to what humanity dared to achieve. Have you ever imagined flying on Concorde? Tell us what fascinates you most, and don't forget to like and subscribe for more aviation stories.